Welcome to the another lecture on communication engineering. I am Ramji, working as an assistant professor in the Department of Electronics and Communication Engineering, GC Tanjavur. In this lecture, we will be discussing about pulse code modulation, differential pulse code modulation, delta modulation, and adaptive delta modulation. Pulse code modulation, or PCM, is a technique. It is used to convert any analog signal into digital data. So this is a PCM generator. Here we have the continuous time signal x of t. This continuous time signal x of t is given to the low pass filter. This low pass filter acts as an anti-aliasing filter. It blocks the frequency component above WH to avoid aliasing. This filter signal is given to the sample and hold circuit. Sample and hold circuit takes the samples from the continuous time signal according to the switching operation of sampling switch and discharging switch. Switches are controlled by the sampling frequency Fs. Then the sampled signal are given to the Q-level uniform quantizer for getting fixed amplitude values. Based on the fixed amplitude values, V bits are assigned to each fixed values in the binary encoder. Then it is given as a parallel to serial converter. It changes the parallel bits into serial bits. Finally, we get the pulse code modulated signal. This is a PCM receiver. We receive the PCM signal, then it is given to the regenerator. It changes the shape of the signal, reduces the noise in the received PCM signal. Then it is given to the serial to parallel converter. It converts the serial bits into parallel bits. Then we have a digital to analog converter to convert the parallel bits into corresponding finite fixed values. This DAC also having a hold circuit to hold the analog value to the particular time. Then we have low pass filter. It gives a smoothness to each level to get approximate continuous time signal. Next one is differential pulse code modulation. The samples of continuous time signal are highly correlated with each other. This is because any signal doesn't change fast. The adjacent samples carry the same information. When these samples are encoded by PCM, the resulting encoded signal contains redundant information. Here, the samples taken from 40s, 5Ts and 60s are encoded to same value, that is 110. It is redundant. So DPCM works with principles of prediction to reduce the redundancy. So this is DPCM transmitter and receiver. In transmitter, the sampled signal is generated by X of NTS and the predicted signal is X cap of NTS. The comparator finds out the difference between the X of NTS and the X cap of NTS. So this is called error, E of NTS. This E of NTS is given to the quantizer and encoder to get the DPCM signal. At the receiver, the decoder first reconstructs the quantized error signal from the incoming binary signal. The prediction filter output and the quantized error signal are summed to give the original signal. Next one is delta modulation. Delta modulation transmits only one bit per sample. That is, present sample value is compared with the previous approximated sample value. The difference between the input signal and the staircase approximated signal confined to two levels, that is plus del and minus del. If the difference is positive, then approximate signal is increased by one step. If the difference is negative, then the approximate signal is decreased by one step. When the step size is increased, logic 1 is transmitted, and the step size is decreased, logic 0 is transmitted. Thus, for each sample, only one bit is transmitted. The principle of delta modulation is explained by the equation. Here, E of NTS is the difference between X of NTS and X cap of NTS. E of NTS is error at the present sample. X of NTS is sampled signal X of t. X cap of NTS is the last sample approximation of staircase waveform. And the U of NTS is the present sample approximation of staircase output. U of n minus 1 TS is the last sample approximation of staircase waveform. And here B of NTS is del into sine of E of NTS. So based on the sine of E of NTS, we can get B of NTS. If here B of NTS is plus del if X of NTS greater than or equal to X cap of NTS, and B of NTS value is minus del if x of NTS less than x cap of NTS. If B of NTS is plus del, binary 1 is transmitted. If B of NTS is minus del, binary 0 is transmitted. Here TS is a sampling interval. At the receiver of delta modulation, accumulator and low pass filter are used. The accumulator generates a staircase approximate signal output and is delayed by one sampling period Ts. It is then added to the input signal. If the input is binary 1, then it adds one step to the previous output. If the input is binary 0, then one step is subtracted from the previous output. The low pass filter gives a smoothness to the staircase waveform to get the x of t. There are two disadvantages in the case of delta modulations. If the input signal is having large dynamic range, and the staircase signal cannot approach from the input signal, then there is error between input signal and the staircase approximate signal. This error is called slope overload distortion. So to reduce this error, the step size should be increased and the slope of the signal is high. The granular noise occurs when the step size is too large compared to the small variation in the input signal. For small variations, the staircase signal keeps on oscillating around the signal. So the solution to this problem is to make step size small. So to overcome the quantization errors due to the slope over and granular noise, the step size is made adaptive to variations in the input signal. Particularly in the steep segment of the x of t, the step size increase. When the input is varying slowly, the step is reduced. This method is called adaptive delta modulation. The step size increases or decreases according to a certain rule depending on 1-bit quantizer output. For example, if 1-bit quantizer output is high, then the step size may be double. For an example, if the 1-bit quantizer output is low, then the step size may be reduced by 1 step. At the receiver, the first part generates the step size from each incoming bit. The previous input and present input design the step size. It is then given to the accumulator, which builds a staircase waveform, and the low pass filter uses smoothness to the staircase waveform to get actual x of t. The next lecture I will be discussing about what is multiplexing, what is time division multiplexing, and frequency division multiplexing. Thank you.